starting in lesson 5.2, we're no longer graphing, but as I said, that does not mean there is still not a graph for the system of equations that you're solving. We're just not using the graphing method to solve it. So we're still going to get ordered pair answers, which would still represent an intersection on a graph, but we're going to get it without graphing. We're going to do it algebraically. So here's what we're going to look for today. We're going to find the equation that is solved for either x or y. In other words, we're going to look at the two equations and we're going to say, are either of them have the x alone or the y alone? And if it does, we're going to circle the expression that that x or y is equal to. If you want to use a highlighter instead, but I suggest you do something to show what were you actually substituting. Okay, so we're going to circle the expression that that x or y is equal to, kind of like I just did over here on the board. I circled the 7 plus 2 and said I'm going to put it in place of this 9 down here, and I still am going to have an equivalent statement. Okay, then, so here's our steps. Substitute the expression into the other equation. So we've done this find the equation set equal to x or y, and we've circled the expression. We're going to substitute that expression into the other equation for that variable. So if it was equal to x, it's got to go in place of an x. If it was equal to y, it's got to go in place of a y. And then we're going to solve that equation. Next, we're going to substitute whatever solution we get there, whether it's an x value or a y value. We're going to substitute that into the equation with the variable alone. Really doesn't matter which of the two equations we use at that point, but you might as well do the one where the variable is alone, because if you're solving for that y and y is alone, you're going to make it work if you use the other one. And then you're going to put your solutions for x and y into an ordered pair, just as if we had graphed it. We'll say the solution for this is, what is going on? Okay. So those are our 3 steps we're going to use. And we're actually going to number those steps so that we understand what we were doing in each of them. Okay? So the first thing we're going to do is we're going to look at the equation in our system, look at our equations, and we're going to see, are either of them solved for x or for y? So is the first one solved for x or y? Meaning, is the x by itself or the y by itself? The y is by itself, right? So this says y equals, y is the same as negative x plus 5. Circle that. Y is the same as negative x plus 5. Whatever y is, so is negative x plus 5, that same thing. Okay? So we're going to take that and we're going to substitute that into the other equation for where that y is, because it says that's what y is equal to. So we're going to kind of like temporarily eliminate the y's. They're going to disappear, and we're only going to have an x to solve for. So step number 1, you're going to write down that other equation that isn't the one that we have the expression circled in. So write down that other equation. Let's change that to add the opposite. I highly recommend you change all subtraction to add the opposite today, because when you substitute in, you want to make sure you do your distributive property and simplifying properly. Okay? So now we'll do our substituting. X plus, we have negative 4, and we're going to substitute in for that y, our circled expression, negative x plus 5. And everything else in that equation stays the same. Only the y gets replaced, and it gets replaced with negative x plus 5. Well, we're not really still quite ready to solve this. We have to do some simplifying first. So what should we do first? We got to do that distributive property. So we're going to take negative 4 times the negative x and times the 5. So this x comes along. Negative 4 times negative x. Positive 4x, and negative times a negative is a positive, and 4 times x is 4x. Bring down our plus sign. What's negative 4 times 5? Negative 20. Okay, and then we bring down our equals 10. We're still not really ready to solve this. We still have some more simplifying we can do. Ricky?
Put the x's together.
Yeah, let's bring those x's together because they're on the same side. So we have 5x plus negative 20 equals 10. So notice the y's eliminated, didn't they? When we substituted that expression in, there are no more y's, so we have just one variable to solve for. We're solving for the x right now. So now we're ready to start solving. We're actually done simplifying. What are we going to do next? Add 20 to both sides. So now our equation reads 5x is all alone over there, and 10 plus 20 is 30. And our final step is what? Divide by 5. So we'll divide both sides by 5. And x is equal to what? 6. Okay, so we just found out that we know that x is equal to 6 in our solution, our ordered pair solution. Any part of that not make sense?
That was all step 1.
That was all step 1.
Huh?
That's going to be the one that'll be involved the most, is step 1. Okay. Now we'll go on to step 2, and it's going to be pretty fast and painless because we're going to use the equation that says y equals, because we're looking for y next, aren't we? So it doesn't matter which equation we use, but it makes more sense to use this one because y is already by itself. So we're going to write down that equation, and we're going to substitute into it now our solution for x. So y equals, that negative sign is not part of that x. It's out front of it. So I'm going to substitute a 6 in for the x, because that's what we got. And then bring down my plus 5. So the opposite of 6 is negative 6. Negative 6 plus 5 is? Negative 1. We just got our solution for y. Step 3, write your solution as an ordered pair. What's our ordered pair answer?
6 negative 1.
6 negative 1. So, as I said, step 1 is going to take the most time. Any part of that we need to talk about? Isaiah?
Will we need to do any check problems in this?
I'm not going to make you do check problems today. Today, my focus for you is to make sure that you just learn how to do the substituting and solving part here, okay? That does not mean you're not eventually going to have to do check problems, but today we are not going to. But if you wanted to make sure, let's say tomorrow I decided at the beginning of class to give you a 1 question, solve by substitution, quick quiz. It's worth 20 points. You either get the whole ordered pair answer right for 20 points, or you get any part of it wrong, it's 0. Would you want to make sure you got the right ordered pair? Or at least try to make sure you got the right ordered pair? So we could do what?
A check problem.
We could do a check problem. We could put, what would we put in here for y?
Negative 1.
Negative 1. So we'd have a negative 1 here. And then what are we going to put in here for x?
6.
6. Well, notice that was just kind of like the one we just did in step 2, wasn't it? So negative 6 plus 5 is?
Negative 1.
Negative 1. Checks out in that one. Okay, we're going to put 6 in for x. We're going to put negative 1 in for y. Let's change this to add the opposite. So that's a negative 4. What's a negative 4 times a negative 1?
4.
4. What's 6 plus 4?
10.
10. It checks out, doesn't it? So then you can feel pretty confident that you have it right. If all else fails, you're like, I really need this 20 points. I can't afford to get a 0 on this. You can set up a graph and try graphing them. Where should these lines intersect?
At 6 negative 1.
At 6 negative 1. Yeah. They will intersect at 6 negative 1. Were these equations in graphing friendly form?
No. Only the first one.
Only the first one was. This is when algebra, being able to solve it algebraically comes in handy, is if you don't, especially if the equations aren't given to you in slope-intercept form, in graphing friendly form, and the teacher doesn't provide graphs for you, coordinate planes for you, and you got to set up your own, make your own. That's when it's kind of nice to be able to know another way to solve. Okay, let's go to the back side and try another one together before we do a word problem. Here's our system. Negative x take away y equals 10. And that equation is it solved for either x or for y? The first equation, negative x minus y equals 10. Is it solved for x or for y? No. So we move on to the other equation. Is it solved for x or for y?
Yeah.
Yeah, it's solved for x. So we're going to circle that expression that can take the place of x. That can take the place of x in the other equation. So here's our other equation. So it's always helpful to write down the system of equations first and take the time to do the circling or take a highlighter and highlight that expression. But before, remember I also said what we're going to do is we're going to help us be more successful, we're going to change it to add the opposites. We have negative x plus negative y equals 10. Now we're ready to substitute. Okay?
I was gonna ask if you should add the opposite of x.
So we're going to do negative, and in parentheses, we're going to put our 3y, and let's change this also to add the opposite, plus negative 2. That's just our x. That's all we've done there. The negative sign comes along. There's what we're putting in place of x. We're going to add negative y to that and set that all equal to 10. Well, a negative sign out in front of those parentheses really is the same as distributing what? A negative 1. So you really can slip a 1 in here and say, you know what, I got to multiply each of those pieces inside the parentheses times negative 1. Or another way to think of it is, I got to take each of them and find it their opposites. Okay? So let's do our distributive property. What is negative 1 times 3y? Or in other words, what's the opposite of 3y? Negative 3y. What's a negative 1 times negative 2, also known as what's the opposite of negative 2? Positive 2. No, it's a positive 2. Okay, so we did our distributive property. Any other simplifying we can do, Isaiah?
Can't we change the 2 plus negative y to minus y?
Add the y.
We can, but there's really no reason to right now because we're going to do some more simplifying first. Hunter? Add the y's together. We got a negative 3y and a negative y on the same side so they can be brought together and it becomes what?
Negative 4y.
Oh, negative 4y. Negative 3 plus negative 1. So negative 4y plus that 2 equals 10. So in other words, we just brought these guys together. Negative 3y and negative y and got negative 4y. Any more simplifying we can do?
No.
No, now we are ready to solve. So what are we going to do first?
Subtract 2.
Subtract 2 from both sides. We get negative 4y equals 8. Divide both sides by negative 4.
Y equals negative 2.
And we find out that our solution for y is negative 2. So this time, we temporarily eliminated the x's so we could figure out what y was equal to. So any part of that we should talk about?
No.
Step 2. Which equation should we use to find our x value?
The other one. The x equals 3y.
Yeah, the other one that we didn't use, I guess you could say. We did, but we didn't. It's set equal to x already. That's what we need to find. So we're going to use x equals positive 3y plus negative 2. So let's put our negative 2 in for the y. And let's get our x value. What is 3 times negative 2? Negative 6. So what is our x? Negative 8. So now we know our x value also. Step number 3, write it as an
Order pair.
okay, what is it? Negative 8, negative 2. X comes first in the order pair, followed by the y. So for those of you who didn't like graphing, maybe you're going to be happy we finally figured out how to do algebraically. Or maybe not. Any questions on this one? Any part you're not understanding?
No.
Okay, then let's go where we have to set up our own system of equations again. Okay. The sum of two numbers is 75. The the second number is 3 less than twice the first number. What are the two numbers? Well, they
X and
didn't
Y.
tell us what either of them are, did they?
No.
So we let X represent one of them, and Y represent the other. So that's the first thing we're gonna
X plus
write.
Y.
No, we're not even gonna write an equation yet. We're gonna say X is. We don't know what value it is, but what's it representing?
X is the first number.
Okay, let's call X the first number. That's kind of how they refer to them, so we can do the same. X is first number. Y is second number. And yes, I expect you to do this part. Don't go straight to setting up the system of equations. It should make it a whole lot easier actually to set them up and make sure that your equations make sense to the problem, okay? So what's one equation we could use and what part of the information helps you set that up? Ricky?
X plus Y equals 75.
Okay, what part of the information helped you set that up?
The sum of two numbers is 75.
Okay, the sum of two numbers. Sum means we better add. The two numbers are X and Y. So there's one of our equations. Who thinks they can come up with the other one for us? Second number is 3 less than twice the first. Ricky?
So would that be Y? Oh wait, no. Y equals 3 minus 2x.
Is 3 less than twice the first. Subtraction's fussy, remember? Going back. 2x minus 3, yeah, y equals. When it says 3 less than, that means 3 better be getting subtracted from something. 3 less than, so they're saying take 3 away from twice the first. So the second number, y, is 3 less than twice the first. There's our system of equations.
I had that last part backwards.
And order matters in subtraction, so you
Right.
would have ended up with the wrong answer, right?
Right.
Okay, so first or second equation is going to be the useful one to start with.
Second.
Second one, we're going to circle what y is equal to. Y is the same as 2x minus 3. So in step number 1, we should be able to use our other equation. And in place of that y, we're going to put our circled expression. And we always put it in parentheses to start with because we don't know if we're going to have to do some simplifying or not. Christian. So how do you feel? Do you think those parentheses are important?
Yep. No.
Not really, because if they're getting multiplied by anything, what's it getting multiplied by? And is it a positive one? Yeah, and when you multiply by a positive one, does it change anything?
No.
No.
And this
So in
is very-
reality, what we have here is x plus 2x. And if we wanted to, we could change that to add the opposite like I suggested, plus a negative 3. And we're still not ready to solve. We got some simplifying still to do. What is it? Add the x's. What do we have? 3x plus negative 3 equals 75. Go ahead and finish solving that one. Get your x value. What is the first number? I get 26. What did you get?
Yep.
Okay, so let's move on to step 2 that says get your other value now. So we're going to use y equals because that's the one we're looking for anyway is y. So we'll substitute 26 in for x and solve it for y. Actually, all we have to do is a bunch of simplifying. 52, take away 3. What's our y value? 49. Okay, first of all, does it pass the test of that if you add them together you get 75? 26 plus 49? Yeah? Okay. And then so the second one is 3 less than, well, if you don't really quite understand what that means, that might be a little harder to check. Twice the first. Well, twice the first is 52. 3 less than that is 49. So we're going to, but for step 3, we're not going to write an ordered pair this time because we know what x and y are representing. So we're going to say 26 is the first number. Because it matters, they have roles in this. 26 is the first number, and 49 is the second number. So instead of writing it as an ordered pair, we know what those x and y's are, so we state it that way. But where would these intersect on the graph?
29, 49, or 26, 49.
At ordered pair 26, 49, they would intersect on the graph. Okay. So any questions on this one? Any part of it? Yeah, I'm not stamping papers tomorrow without, if there were papers sitting that didn't have the variables described. And then equations set up, and then solve. Today we're not solving by graphing, we're solving by substitution. And then last but not least, some of these were probably not an ordered pair answer for these, but instead write out what those numbers are really actually telling you. Okay? So you can get started on your homework. Be really careful though, write down the problems that I want you to do, because tomorrow we're gonna have to do something else, and then it's just gonna grow in complexity. So you want to do the ones that are not going to confuse you too much yet today.
I have a question.